Okay, we're going to do the example now. They do give us a figure, but I want to point out you should be able to generate your own figures. So what do they have? They have two curves, and one curve is a parabola, the other curve is y equals x. So I'd like to visualize that, and certainly I'd like to visualize a region from that. And what would you get? You would get a line like this that goes to the origin, and you get a parabola like this over here, which also goes to the origin. We have 2 points of intersection, relatively simple. The point over here is going to be 1, 1, and the point over here is going to be 0, 0. What's the region? This is the region. All right. What are they going to do? Well, they're going to rotate it. How are they going to rotate it? About the y-axis. Look, let's rotate it like this, and there's many ways to do that, but we're going to do it by shell. So I'll put the shell down. Right, I'm going to put the representative rectangle down, and they're going to draw that rectangle like this. But as I rotate it, it's going to create a shell, all right? So when this thing rotates around, it's going to create a shell that looks like this over here. What's a differential? Dx. What's this length over here? That's the circumference of that shell, and that corresponds to a radius of x, so that's going to be 2 pi x. And what's the height of this thing over here? Well, it's going to be the upper curve, which is going to be y equals x, and the lower curve is y equals x squared. So the height would be x minus x squared. Let's write that down as the volume of that shell. So the volume of this shell, this is just one shell of many, is going to be, let's see, 2 pi x. That's the length of it. The height of it's x minus x squared. And the width of it is dx. And what we got to do now is add the shells together. Let's go back to black ink now and write our integral down. Our integral, looking at our picture, going along the x's, goes from 0 to 1, 2 pi x, this is a representative shell, times x minus x squared dx. Simplify, 2 pi comes out, you get 0 to 1. Let's simplify the integral by multiplying it out. You get x squared minus x cubed dx. You're going to get 2 pi. The antiderivative is x cubed over 3 minus x4 over 4. And we're going to go from 0 to 1. Relatively simple integration, and we'll check it with the k. What do you get over here? 2 pi. Upper limit's going to be 1/3 minus 1/4. And the lower limit's 2 pi times 0. So what do you get there? 2 pi. Common down there, 12. You can get 4 minus 3, which is 1. So what are you going to get over here? Pi over 6. All right, let's look at the k and make sure we got it. I also want to point out they give a much better picture. I see a shell. I see the height of the shell. I see clearly I see the differential looking at this. Differential is dx. Again, the height of it, upper minus lower. As we said, the radius of the shell is just simply x, and this is the radius. And again, we just went through that. But again, having a good visual can be helpful. It's better than my little visual over here. But the bottom line, if you don't have visual, you still should be able to do the problem. Thank you.